Let's do another example. Here we have a linear transformation T that goes from R2 to R2, and we want to find the standard matrix A of transformation T if T rotates each vector 60 degrees counterclockwise. So as before, we know that the standard matrix A of transformation T, the columns of A are just going to be the transformation on the vectors in the standard basis. So the transformation on vector I, the transformation on vector J. So if I can find how the transformation affects these vectors, I will know the standard matrix of transformation T. Now, since T rotates each vector 60 degrees counterclockwise, I know it will rotate these vectors 60 degrees counterclockwise. All right? So let's kind of draw it out to get a feel for what's going on here. So I have, say, vector I. Let's say it's right here. So this is vector I. And I have vector J. Okay. Now both of these are unit vectors, so they have length 1. I want to rotate both of these 60 degrees counterclockwise. So 15, 30, 45, 60 degrees. So this would be T of I after we rotate it 60 degrees. Okay, so we need to find what T of I is, which means we need to find the components of this vector. So I know that the length of the vector is 1. So if I kind of think about this as a 90-degree triangle, this 30, 60, 90 triangle, I know the ratios of the sides are 1 to square root of 3, right? So normally it'd be, let me draw it over here actually. So I have 60 degrees. The ratio of the sides of a 60-degree triangle are 1, 2, square root of 3. Longer sides opposite bigger angles. Okay, one's the shortest side, opposite the shortest angle, 30 degrees. Root 3 is the next biggest number, so it's opposite the next biggest angle, 60 degrees. The longest side is 2. That's our hypotenuse. It's opposite 90 degrees. Okay, now, of course, these aren't the sides of the triangle we actually want. The triangle we actually want has a hypotenuse of 1. Okay, so these just give me the ratios of the sides. So if I divide everything by 2, that would give me a 1 here. And the other sides will now have the correct proportions. Okay, and so from this we could see the x is 1/2, y is root 3 over 2, and so the transformation on I is 1/2 root 3 over 2. That's the new vector. Okay, we want to do the same thing with J. $15, $30, $45, $60, something like that. Oops. We have 60 degrees here. Now, rather than using this angle, I'm actually going to use this angle. Since I know all of this is 90 degrees, if this is 60, then this angle must be 30. Okay, and I could use the same triangle. It's still a 30, 60, 90 triangle. It's just that this is the 30 now, this is the 60. So the ratio of the sides will remain the same. This will be 1. The angle opposite 30 is 1 over 2. The angle opposite 60, or the side opposite 60, has length root 3 over 2. Okay, and then we just got to keep in mind what quadrant we're in. We're in quadrant 2. The x, the horizontal component, is negative. So TJ is 1/2 negative root 3 over 2. Okay, so my standard matrix A, the columns of A are just TI and TJ. TI was 1/2 root 3 over 2. So 1 over 2, root 3 over 2. TJ is 1 over 2, negative root 3 over 2. Nope, I'm sorry. I did that wrong, didn't I? I mixed up the x and y's for TJ. Let me just swap those. Negative root 3 over 2, 1 over 2. The x component needs to go on top, right? So negative root 3 over 2, 1 over 2. Okay? That's the standard matrix. That's the answer. So the linear transformation, Tx equals 1 over 2 root 3 over 2, negative root 3 over 2, 1 over 2, times vector x. This transformation, this matrix multiplication, will rotate any x in R2 60 degrees counterclockwise.